So the next one is BFS. So here if I have any graph, so here what it will do is, this is a breadth first search. So if there is a start node, all the neighbors of it will be processed, and that the first neighbor will be taken and then all its neighbors will be processed. Take the second neighbor, all its neighbors are going to be processed. So it moves down level by level. So if we have this particular graph, I start from 0 and then I'll process 1 and 2. Then for 1 it is 3 which is unprocessed, it will process 3, and then it will come to this 4 is unprocessed, so it will process 4. The algorithm is, I will have a queue and a visited one. Till the queue is not empty, I will keep taking one vertex and I will check if it has a neighbor, and if it is not visited, I will put it into the queue and I will mark it as visited. So once it goes to the queue, it is marked as visited. Let us see the implementation of this one. So I have the same graph. For the same graph here, I'll call BFS. Now BFS, I mark visited equal to set, Q equal to DQ of start. So here I'm creating a visited, and then I'm including a start node to the queue node, and to the visited also I'm adding the start node. Now here in queue, I will take the leftmost element, that is the first element, and I'm going to print it. If there is any neighbor, for every neighbor that is not visited, I will add it to the queue and also add it to the visited set. Now let us see what happens here. So initially there is A. A will get added to visited. So initially, as per our processing, A has come to the visited set. For every neighbor, now it will print, it will take A is added to the visited and A is also added to the queue. It will pop. Now here it will call the queue, it will retrieve elements from the queue. So initially it is going to print A here. For the neighbor, so now it has two neighbors. What are the neighbors? Those neighbors are, and both are not visited. So those neighbors here are B and C. So what does it tell? Added to visited, also added to queue. So here B. Now A is removed from the queue. So here B and C will get added. Now it will pop the leftmost element, which is B, and B is now removed. It will print B here. For every neighbor, that will be D. So D will get added over here. D will also get added over here. And then it will come to C. C will not have any neighbors, that so it will pop, remove C from here, and it will be printed. So once C is processed, it will see that there are no neighbors. Again Q will continue and D will be removed from the queue. It will get printed. And finally this is how it gets printed. And all the nodes are also marked as visited. Q is left as empty. So once the queue is empty, it will come out of the loop.